Okay, so lesson 2.7, derivatives of sine x and cosine x. What are the derivatives of this function sine x and the derivative of cosine x? I'm going to do a proof of what the derivative is. This is just kind of like not necessary. I can just give you what the derivative is, but I think it's pretty good to understand where it comes from, algebraically speaking. So here it is. Let f of x equal sine x. So I'm going to use the definition of the derivative to prove it. So f prime of x will equal to the limit as h approaches 0 of the function f of x plus h minus f of x over h. So we're going to use this definition to prove it. Alright, so let's go ahead and do it. So this is going to equal to f prime of x will equal to the limit as h approaches 0. Okay, so we have here f of x plus h, f of x plus h. So for every x in sine, we're going to plug in x plus h. So we got sine x, and for x, we're going to put x plus h. So I have sine x plus h. All right, and now I'm going to subtract f of x, where f of x is sine x. All right, over h. Okay, good so far. We are going to use what we did in the warm-up here. There's the sum of that one identity we did. So then this is going to be equal to the limit as h approaches 0 of, how did it go? Wasn't it sine x cosine times cosine h plus cosine x times so it was sine x times cosine h plus cosine x times sine h. Okay, if we remember what was that identity, and then minus sine x over h. So now you're like, so what do we do next here? What we're gonna do is maybe we have three terms on top. You see, we got, this is one term, this is another term, this is another term. What I'm going to do is put these next to each other, this with this last term. Let's put those next to each other. So what I'm going to do is do this. Lim h approaches 0. And I'm going to go ahead and put sine x times cosine h minus sine x. And then put this plus cosine x sine h over here after, over h. Then I'm going to factor out sine x from these two. Let's do that. So we're going to equal, this is going to equal to lim h approaches 0 of, factor out the sine x, and then I'm going to have cosine h minus 1, okay, plus cosine x times sine h over h. Okay, so now we're gonna move, let me go up here. What I'm gonna do is I'm just gonna like separate this and then separate this. So what we're gonna have now is lim h approaches 0, lim h approaches 0 of sine x times cosine h minus 1 over h. And we're also going to distribute the limit. So, and then we're going to go here plus the limit. Or you know what? Let's just separate it for right now. Plus cosine x times sine h over h. So the limit as h approaches 0 of this quantity. So as we continue here, we just have a limit for each one of this. Let's go ahead and do the limit as h approaches 0 of sine x cosine h minus 1 over h plus lim h approaches 0 of cosine x sine h over h. There's the limit properties. We can factor out the sine x because it's about h approaches 0. So sine x, we can just factor that out. So I'm going to factor out the sine h. So we're going to have sine x factored out. Then we got lim h approaches 0 of cosine h minus 1 over h plus lim h approaches 0 of, let's see, we can also factor out the cosine x here in this one. Okay, so yeah, let's factor out the cosine x. So then here we're going to have plus cosine x lim h approaches 0 of sine h over h. All right. So here, I think we already, this is the limits that I told you from the warm-up. We did this limit, and that limit was 0. But in the other one was like something like x approaches 0 and cosine x. It doesn't matter, h or h is just the variables. So this is 0. So you got 0 times sine x will be 0. And for this one, it was lim h approaches 0 sine h over h. It was x approaches 0 sine x over x. That one is 1. So then you got 1 times cosine x. So it's going to be plus cosine x times 1. And so 0 plus cosine x times 1 is cosine x. So the derivative of sine x is cosine x. The derivative of sine is cosine. The derivative of sine x is cosine x. Alright, let's put it into practice. Well, actually, you know what? I'm not even going to do the proof of cosine x. Here it is, the derivative of cosine x. I'm just going to go through this quickly. And I don't want to do this proof anymore. But the derivative of cosine x is going to be negative sine x. The derivative of cosine is negative sine x. Alright, let's put it into practice. Problem 1. So, all you gotta do, I'm gonna write it down right here. The derivative d dx of sine x is what? Cosine x. D dx of cosine x is negative sine x. Okay, so you need to know this. Alright, find an equation of the tangent line to the graph of f of x equal cosine x at x equals pi by 2. This is repetitive. We keep going with finding tangent lines. Okay, it's this point slope formula. So the input is pi by 2. The output, okay, what is then plugging x equals pi by 2 into cosine? What's cosine pi by 2? To find the output. Pre-calculus again. Go back to the unit circle. Pi by 2. Pi by 2 is up here. This is x is what? 0. Y is 1. So cosine of pi by 2 is, because this is pi by 2, 0. There it is. The output of cosine pi by 2 is 0. Because x is cosine. So here's the calculus. Finding the slope. If you're given f of x is equal to cosine x, the derivative of cosine x, f prime of x, is going to equal to the derivative of cosine x is negative sine x. And now we just got to evaluate it at pi by 2. F prime at pi by 2 is going to be equal to sine pi by 2. So what is sine of pi by 2? I should not erase the unit circle. Pi by 2 is here. And what is sine of pi by 2? 1. Put the 1 here. And we're done. That would be the answer right here. You can even clean it up a little bit more and say y is equal to x minus pi by 2. Distribute this and that would be the answer. Yeah. Let me go back. Look at this. Don't do this mistake I just made. Look at this. Negative sine x, negative sine x. So it would be negative 1. Because it's 0, this is 1. And so sine of pi by 2 is 1, but we got negative in front of it. So it should be negative 1. So that makes this negative and then plus pi by 2. Hey, happens to the best of us here. So everything should be good. Let's review the unit circle here. The unit circle. Just memorize these, okay? So the unit circle is 180. This is 180 degrees. That's pi. Pi by 6 is 30 degrees. It's right here, the unit circle, and then goes counterclockwise to know the unit circle. This is pi by 4, 45 degrees. Pi by 3 is 60 degrees. 90 degrees is pi by 2. Memorize that. 2 pi by 3. How do we quickly get these other ones? Basically, you see this pattern here. This one is related to this one here. All you got to do is kind of subtract this number here in front of pi is a 1. 3 minus 1 is 2 pi by 3 right here. This one, there's a 1 here. 4 minus 1 is 3 pi by 4 here. So if this is true, then you can put a 1 here. 6 minus 1 is 5 pi by 6. Right here, 5 pi by 6. You want to get these ones down here. You want to go this one right here. You're adding actually to pi. You're adding another pi by 6. So you're going to get 6 plus 1. You're adding. So this is going to be 7 pi by 6 down here. The unit circle. Add the bottom to the top. 4 plus 1 is 5 pi by 4. The next one down here, this one down here is going to be 3 plus 1 is 4 pi by 3. 2 plus 1 is 3 pi by 2. Go straight down right here on this one to find this next one over here. 5 pi by 3. 4 plus 3 is 7 pi by 4. 11 pi by 6. And 2 pi. How do you find the actual outputs or what are the sines and cosines here? I'm going quickly over these things. X is always cosine and y is always sine. That's all you got to know. X is cosine, y is sine. So whenever somebody says what's the cosine of 0 degrees, because there's 0 radians, it's going to be 1. And then the y value is the sine, and that's 0. So if we go to the top, that one is going to be x is 0, but the y is 1. So whenever somebody says, what is the cosine of 90 degrees, or pi by 2, cosine of pi by 2 is 0, sine of pi by 2 is 1. Over here, that's going to be x is negative 1, y is 0. So whenever somebody says, what's the cosine of pi? Cosine of pi is negative 1, sine of pi is 0. Down here, x is 0, y is 1, negative 1, negative 1. So somebody says, what is the cosine of 3 pi by 2? The cosine of 3 pi by 2 is 0, and the sine of 3 pi by 2 is negative 1. And over here, we already did this one. These ones here, to memorize, we just got to memorize these ones here quickly. I'll tell you how to memorize these ones quickly. So whenever somebody says, what's the cosine of pi by 6? What is the sine of pi by 4? What is the cosine of pi by 3? You should be able to quickly get these ones here. How do you do it? Everything will be over 2. Everything will be over 2. Everything over 2. And then you're going to get the start at the top left and start with the square root of 1. Square root of 1 is 1. Square root of 2 is square root of 2, leave it alone. Square root of 3, square root of 3. Here, this one's going to be start over. Start with 1 again. And take square root of 2 is square root of 2, square root of 2, square root of 3. So that's it. There it is. So anybody asks, or you need to know what is the cosine of pi by 6. Cosine pi by 6 is root 3 over 2. Sine pi by 6 is going to be 1/2. Cosine pi by 4, root 2 over 2. Sine pi by 4, root 3, what is that? Root 2 over 2. Root 2 over 2. Cosine pi by 3, cosine pi by 3, 1/2. Sine pi by 3, root 3 over 2. Everything over 2. 1, root 2, root 3. 1, root 2, root 3. And there it is. To fill out the rest of these, go across. These x's will become negative. These x's will become negative. These x's will become negative when you go straight across over here. The y's stay positive. You can go down. This one goes here. The x's and the y's are both negative. Both will become negative down here because it's negative and negative. So all of them are negative. You want to go down right here. These ones go down here. The x's are positive, but the y's are negative. So whenever anybody asks you any kind of question about what is the cosine of 11 pi by 6, it's going to be this. The sine of 11 pi by 6 will be this. Finish this off. Problem number 2. What is the limit as h approaches that of that? What would it be equal to? The way to do this problem, and I'm just going to give you a trick, is to identify what is the function and where is it evaluated at. Evaluated at what? A equals what? That's what you need to know. The function is going to be sine of x evaluated at 7 pi by 6. So now all you got to do is take the derivative evaluated at that point. F prime of x is going to equal to the derivative of sine x is cosine x. And now we're going to evaluate at that point. F prime at 7 pi by 6 is going to equal to cosine of 7 pi by 6. 7 pi by 6. So what is cosine of 7 pi by 6? Cosine of 7 pi by 6. So go back to the unit circle. Pi by 6 is related to pi by 6. You need to figure out where is pi by 6 at. Pi by 6 is here. Pi by 6. 7 pi by 6 is going to be 6 plus 1 is 7 pi by 6 is going to be over here. So this pi by 6 is going to be what? Pi by 6. This one goes like this. Remember what we just did? Everything over 2. So everything over 2. So this one was 1 over 2, root 3 over 2. This is root 3 over 2. And we're looking for a cosine. So x is cosine. So now we're going over here. So this one is going to be root 3 over 2. And this is whatever this is. But this is negative because everything's negative on this one here. So the answer is going to be negative root 3 over 2. Negative root 3 over 2 is the answer. That would be it for this section.